advanced course on advanced algebra, precisely hyperbolic function. Okay, so we have evaluate Cosh 1.321 and then evaluate sine inverse of x in log form. Alright, so we have solution. We have the first question says to evaluate Cosh 1.321. Okay, so 1.321 is actually the value of x. Okay, so well, we know that formula for Cosh x is equal to exponential x plus exponential minus x over 2. Okay, so x being 1.321, we're going to substitute the value of x there, so that Cosh 1.321 is equal to exponential 1.321 plus exponential minus 1.321 all over 2. Okay, then using the calculator, exponential 1.321. Exponential 1.321 will give us 3.7472. Then plus the negative will give us 0.2669 all over 2. Okay, and then we're going to add the two numbers together. 3.7472 plus 0.2669. We have 4.0141 divided by 2, and the final answer becomes 2.00705 becomes our answer. Alright, so if you want to get exponential 1.321, if you don't actually know how to get it, you can see, let's extend now. You can have, there's the shift function here, shift, then you click on the button here, IN, lane, or the oct. You click on the button, you will see exponential, then put your number 1.321 equal to. Okay, we use the first 4 decimal places, so the answer becomes 3.7472 in 4 decimal places. Then the other one, you can quickly just go use this upward key to move the cursor back to the question. You see, then you regulate it, go to the power behind 1. As you can see, you're gonna have put minus there. Okay, then equal to display the remaining one, which is 0.2669. Okay, all right. The second question there, B. We have to evaluate sine inverse of x in log form. Okay, so sine inverse of x in log form, the first thing we do is to write y equal to the question, which is sine inverse of x. Okay, so we are now looking for the value of y. Okay, the value of y. So if y is equal to sine inverse of x, of course we are about to derive the formula for the sine inverse of x. Okay, to derive the formula for sine inverse of x, which will be in log form. So sine inverse, that's the hyperbolic function, sine of the inverse of the hyperbolic function. You take it to this side, it will give you the normal sine h of y equal to x. Just as when you say sine theta is, let's say 0.5, and you want to find theta, theta is equal to sine inverse of 0.5. If you want to take this sine inverse back here again, if the sine inverse crosses back here again, it will change to the original form, which is sine theta equal to 0.5. So sine h inverse of x, if you take away this h inverse to cross to this side, it will turn to sine h of y. That's sine h of y. The inverse will be removed. Okay? So we have sine h of y equal to x. Then recall that the formula for sine h of y, recall that the formula sine h of y is equal to exponential y minus exponential minus y minus y minus y all over 2. Okay, so if that happens to be the very case, we're going to remove this sine h of y and replace it with this. We have exponential y, and replace sine h of y with the formula minus exponential minus y over 2 is equal to x. And remember, we are solving for the value of y, okay? So we cross multiply here. We're going to have exponential y minus exponential minus y equal to 2 times x is 2x, okay? So we now have exponential y minus the indices there. To remove the negative, we have 1 over, of course, exponential of the positive power equal to what? 2x. So the LCM of the denominators here, as you can see, the LCM is exponential y. We're going to multiply through by exponential y. Okay? That happens to be the case. Exponential y will multiply this guy to give me exponential y all square, okay, minus exponential y multiply this guy to cancel out. We have minus 1. Exponential y multiplied by 2x is 2x exponential y. Then when you rearrange this equation, we have exponential y all square, 2x exponential y cross to this side is minus 2x exponential y, then minus 1 equal to 0. So this is kind of looking like a quadratic equation, and that happens to be the case. Of course, a is equal to 1, where exponential y is a variable here. That's the unknown. B is equal to the coefficient of the unknown, which is minus 2x, because the unknown here is exponential y. So exponential y squared, the coefficient is 1, that's a. Then exponential y, the coefficient here is minus 2x. And of course, the last number there, the constant, is equal to c. Okay? So we now have our formula exponential y to be equal to the almighty formula. That's the general formula for quadratic equation, which is minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So we have exponential y to be equal to minus into what are b? B is minus 2x. Okay? Plus or minus the square root of b squared, of course, minus 2x all squared minus 4 times a is 1 and c is minus 1, okay? All over 2 times a, which is what? 1. So we have exponential y is equal to negative is positive, so we have 2x plus to minus the square root of minus 2 square, we have 4 plus 4, then x squared is still x squared, so we have x squared. Negative here multiplied by negative here is positive. So minus times minus is plus. We have 4 times 1 there is 4. All over 2 times 1 is 2. So my exponential x is equal to 2x plus 2 minus the square root of course. 4 is common here. We factor out 4. Inside the square root, you can see 4 here, you can see 4 here, so you factor out 4. You factor out 4 into 4, we have x squared, plus, of course, 4 going to 4 will give you 1. Okay? All over 2. And coming up here, we have exponential y to be equal to 2x plus or minus, of course, the square root of 4. Inside the square root, you can see 4 now. You can take the square root of 4, which will give you 2. Then the square root of what's now remaining is x squared plus 1. All over 2. Okay? From the denominator, from the numerator, I see 2 is common. We can factor out 2. When you factor out 2, we have x plus the square root of x squared plus 1 all over 2. So 2 here cancels out 2. We have exponential y to be equal to x plus the square root of plus or minus the square root of x squared plus 1. Then to find y, okay? To find y alone, y is simply equal to remove the e now, we are going to find the natural logarithm, that's the exponential logarithm on both sides, and of course that's the length of x plus or minus the square root of x squared plus 1. That's all. On introducing length on the right hand side, you eliminate the exponential term. Okay, it eliminates the exponential term. That's when you apply the natural logarithm on both sides, the length of the right hand side, and of course the length of exponential y will give us what? Y. Okay, if you must show that, you can say that's what actually happened there is the length of both sides. Taking the length of both sides, length of y is equal to the length of x plus or minus the square root of x squared plus 1. Okay, so the y here, which is the power, will come to the back. We have y length e is equal to the length of x plus or minus the square root of x squared plus 1. Okay, so the length of e is equal to what? 1. So y is equal to that. It's by the way. So once you get to this particular stage, y becomes equal to the length of the right hand side. You have your answer. Okay, but finally, y cannot go with the negative value. Okay, because the value of x in the square roots will be more than x. Okay, taking x to be 1, taking x to be 1, you see that we're going to have length 1 plus or minus the square root of 1 squared plus 1, and the 1 squared plus 1 will give us 2. And if we use negative to solve, we have square root of 2 is already more than 1. Square root of 2 will give you 1 point something. And then 1 minus a number greater than 2, that's the square root of x squared plus 1 is greater than x. The square root of x squared plus 1 is greater than x. Therefore, the value of y is equal to the length of x plus the square root of x squared plus 1. So the value of y has only one real value. So we're going to use only the positive and then we ignore ignore the negative sign.